Look. All right. So we're going to look at the discriminant. It says find the discriminant. So we're just going to go straight to find the discriminant of this. X squared minus 2x plus m is equal to 0. So a is 1, b is negative 2, and c is m. Okay. So the discriminant is here. So our discriminant value is minus 2 squared. So b squared minus 4 times 1 times m. And we get some value for this, 4 minus 4m. Okay. All right. So we need, well, there are 3 answers we're looking for. Depending on what m's value is, we do have the 3 options for the equation. It'll either go through twice, it'll either have a repeated root, or it won't have any real roots. It'll have all 3 of those, depending on the value of this. The easiest one to find is usually this one, because we can let the discriminant equal 0. So that's what I'm going to do. I'm going to find the one where it's the repeated root, because that is where the discriminant equals 0. Because when it's in the quadratic formula, you'll be adding and subtracting 0, which gives you the repeated root. And of course, that doesn't give anything over 8. That gives m is 1. Okay, so that is our repeated root. So part A, that was part A, wasn't it? Repeated root. If m is equal to 1. So if I put 1 in here, it would be a perfect square, wouldn't it? It would be x minus 1 squared. So a repeated root, yeah, sweet. You probably could have figured that out by just looking at it now as you go back and think about it. So we just need to be, it's not too bad for this one, but 2 distinct real roots. We want the discriminant for 2 distinct real roots. We want the discriminant to be greater than 0, yeah? Okay?
We want the second part, minus 4m.
So we want minus 4m is greater than negative 4, yeah? We want to, so what do we do with the sign here? That's if you're changing this sign, you got to change that sign and that sign, don't we? So it's 4m greater, less than 4 for it still to be true, yeah? And then m has to be less than 1. Is that what you said, Aidan, or you said the other way around? I can't remember. Okay, m has to be less than 1 for it to have 2 real roots. Okay, so our balance point was 1 is if m is less than 1. And you can come back up here and you can kind of see that that's going to work out. Because if m is a negative number, for example, if that's negative times this negative, you're going to make a larger positive, which is going to be okay. But if this is positive and it's a large number, like if m is like a 100, you're going to be taking away 400 from whatever square this is, and it's going to be a negative number under our square root, which is not allowed. So you don't even need to work out the other one, because the converse must be the case. If m, so the balance point is 1, and one way it'll be greater than one way.
So as long as, what's it called, the discriminant is greater than, it will always have 2 roots.
Yes, yeah, as long as it's, so 1 was the balance point. If the m is less than 0, kind of counterintuitive a little bit. If m is a smaller number, it'll have 2 real roots, and if m is greater than 0, it'll have no real roots. Or greater than 1, sorry, not 0. Yeah. Okay, and that's, if you think about it, maybe the translation that would do, it would be a vertical shift up, wouldn't it? If it had if m is like 50, that would bring the whole equation up 50, because that's where a constant is. And that would mean it's further away from the x-axis, and that would kind of make sense too. Okay, so you do these. Yeah?
If you just answered like 1 minus 5, 0, I mean, technically they are...
No, so you found a value, yes. The word values there is very important. You have to find a range of values.
So do we have to find a range for this question?
Yeah, to hence find the values for m means all the values. So we found all the values, is literally infinite values past this, and infinite values that way. To find one value, yes, you can definitely easily find one value that makes the discriminant positive and one value that makes it negative. We want to find all the values. So that's why finding the balance point first, and then working off that. Even if they don't ask it in that order, which I think this one mightn't. Oh, it does. Find the balance point. So let the discriminant equal to 0 first, and then work off that.